regarding the power transfer, and you can write notes here before. We said in the last class, if you have a generator, this generator is connected to certain bus, and there are some power transmission lines. Assume we have transmission line 1 up to transmission line number n, and this is called sending end bus, and this is receiving end bus. So the power, the maximum power that can be transmitted to the receiving end, power receiving maximum, can be calculated as a function of synchronous generator. How it can be calculated, Jabab? We know the relation of power equal EF of synchronous generator multiplied by V. But instead of V terminal of the generator here, it will be V of the receiving end. So it's a V receiving end over summation of X from generator to the receiving end bus. So we have here XS. And here we have many transmission line of parallel. Each one has X transmission. So if you have N parallel transmission lines, each has X transmission value. So the total X will be X transmission over N. Tamam? So this is the equivalent transmission reactance. So we can say the total reactance now X S plus X transmission over N. So this would be the maximum possible power that can be received at the receiving end bus. Right. The question now, this is a maximum power, and we said it's a function now of the transmission line impedance. So if you lost one of the transmission line system, this is going to change the amount of power. طبعا it should be decreased شباب. صح كده? Because you already lost one of the power here. So you have a relation between the transmission line that can be used to transfer the power and the impedance of the transmission line. For that, why we need to use many transmission line in parallel like that, شباب? طبعا if you have only one transmission line, and if you got any problem on this line, fault or anything causes an open circuit for this transmission line, you will lose all of the system. So in order to keep the power moving from generator to other receiving end, we should use many transmission line in parallel as a backup, okay, in order to transmit part of the power and not completely lose all of the power. So this is the idea of using many transmission line in parallel. And the maximum power that can be transferred can be calculated using this relation. تمام يا شباب؟ طبعا maximum power means delta equal 90 degrees. So we did not consider delta here in our relation.
Doctor.
تفضل.
There is 3, right? It is 3 times EF and
يعني احنا دايما بنشرح الريليشن بتاعتنا per phase. Okay? يعني this is for per phase value. If you have many phases, you should multiply by n or m, whatever. تمام؟ يعني if you just got 3 phases, you should multiply by 3. And these values are phases values. Okay? Is it clear?
Yes, thank you.
Yes, thank you.
Okay. Fine. Let's start in the in our problems today.
Doctor, you forget to record.
Forget what?
To record.
I think I started recording.
Yes,
It's recording. It's recording, Victor.
It's recording. Okay, it's recording. Fine. So let's start in the problems. I solved some problems يا شباب in the morning session. يعني I do prefer to يعني discuss different problems and share all of problems to you. تمام؟ يعني I will share the morning problems for you and I will solve extra problems to have a يعني variety in problems for both of sections. تمام؟ يعني this is going to help you to have more problems. تمام؟ So let's start instead of problem 1 and 2. I will modify a bit in problem number 2. Yeah, this problem, and this here we have certain loading condition. I will assume that the machine draws a current of 50 amps. And power angle is 15 ampere. Yeah, this is all. This is all what we need. Right. So as you can see, شباب, so this is now not problem 6.8. This is another modified problem. Let's say external. So we have three phases, شباب, 250 horsepower, 2300 volt, 60 hertz, star connected, non-salient rotor synchronous motor. Has a synchronous reactance of 11 ohms per phase. When it draws 50 amps, the power angle is 15 electrical degree. Neglect ohmic losses and also rotational losses. So we say here, neglect all of machine losses. Okay. Now, determine the excitation voltage per phase. طبعا يا شباب يعني recently when we solve problems for any problem يا شباب, in order to get excitation voltage طبعا we get EF with angle delta شباب. تمام, using our relations. We have to define a loading condition. In order to use our relations, يعني you know relation of EF equals V terminal plus or minus JIAXS, طبعا minus for motor plus for generator. صح يا شباب? This is our relation if we neglect the armature resistance. طيب what will be the loading condition يا شباب? Loading condition means you have the current and power factor. Okay, or you have power and power factor, or S, apparent power and power factor. This is the data of the loading condition. If you have B, S, or I with power factor, you can now get the vector of current, which is IA at angle plus or minus phi, plus in case of leading power factor, minus in case of lagging power factor. Do you agree with me, Shabab?
Yes.
If there any problem, so now it's very clear if we have this data. If we have this data here, we can get the current, and based on that, we can simply use this relation in order to get the excitation voltage. Now here in this problem, you can see that the current is given without power factor, and the excitation voltage is unknown. However, the power angle is given. So, yani parts of vectors are here. However, other parts are not defined. So what we can do, Shabab, we can use the triangle relations or solving by using graphical way. How we can solve using graphical way or triangle relations. This is what we are going to select. اتفضل. Any comment or question يا شباب؟
دكتور
اتفضل.
we have the power angle, right?
We have the power angle delta and the armature current IA. Can you use any relation now?
No. What's confusing me, all the losses are we neglect them, so Bn must be equal 0, right?
لا. If losses are neglected, B input will be equal to B output, not equal 0.
Since the rotational are neglected.
If rotational and copper losses are neglected, in this case, P input will equal to P output.
Oh, so the rotational here is not neglected.
لا, again, don't mix between losses and power. Just a moment. We discussed before the power flow يا شباب. Power flow of the synchronous machine. We have P input. Assume we operate as generator. P input mechanical. Torque shaft multiplied by omega. You will have some rotational losses. The remainder will be developed or be converted. Then you will have some copper losses. And finally, you have B out. So if you neglect copper and rotational loss, this means that B out equal B developed equal B input. It doesn't mean B input equal 0. صح؟ يعني if
Yes.
we have 100% efficient generator, is it means B input equal 0 or means B input equal B output?
If there is losses, then it will not be equal.
If we have losses, this means we have lower than 100% efficient. This is logical. However, the question here, if we have losses, sorry, if we neglect losses, in this case, B input will be the same as B output. The same is for motor also, شباب. Motor, B input is electrical power. We have some copper loss. Then the power remaining will be developed. Then we have some rotational loss. And the remainder will be P output. This is mechanical, which is torque shaft multiplied by omega. تمام? Here P output is electrical, which is E3EF, the eternal over XS sine delta, or the phase I phase power factor multiplied by 3. This is the relation of power. طبعا here power will be electrical the same. تمام يا شباب؟ طيب.
دكتور
اتفضل.
when is the case Pn equals 0?
Pn equals 0 if you have also P output equals 0.
But how come that Pn equals 0? What's the job of the machine here?
We discussed in the last class, synchronous motor can be used if it is no load. If it is no load and we neglect all of
To improve the power factor.
So, exactly. So P input equals 0, and in this case, we can consider it as ideal capacitor.
Okay, so in this case specifically only.
Exactly.
Okay.
Exactly. This is only in the case of no load. This is only we have Pn equals 0. تمام؟
Okay, now clear.
Good. طيب. Again, شباب, let's return to the idea of our problem. We have now armature current, we have reactance and power angle, and it's required to calculate EF. طبعا we have also V terminal. طيب, in this case يا شباب, the solution, the graphical solution will be the key of يعني solving this problem. طب how we can do it graphically يا شباب. Again, we have IA equals 50 ampere, so we can calculate IAXS as 50 multiplied by 11, so it's a 550 volt. We have V terminal equal to 2300 volt over square root of 3. This is the terminal phase, okay? And we have power angle delta equal 15 degree. طب how we can solve يا شباب? Let's draw together the phasor diagram to scale. Let's see the graphical solution or solution using to scale phasor diagram. طبعا to scale it means you have to make a scale for your A voltage values. طب now this is exactly if you calculate 2300 over square root of 3, the result will be 1327.9. So this is 1327.9 volts. يعني in order to draw with a reasonable scale, you can make 100 volts here for this number. You can make 100 volt equals 1 centimeter. So if we assume the solution will be like that, assume 100 volt equals or equivalent to 1 centimeter, and start drawing your phasor diagram based on that. So we can draw our phasor to scale. So we can start with V terminal, assume starting from that point. Okay, let's make it ungrid first to be clear for you. So this is, assume this is V line يا شباب. يعني I will not write it here to scale, but I give you only the idea. You can draw it to scale and get the numbers. So this is now V terminal, and we assume that this will be 13.8, يعني almost 0.3 centimeters. Is it right, شباب? So V terminal now here it's around 13.38 centimeter. Let me write the length. So this is V terminal equals 13.3 centimeter. طبعا يعني approximately يا شباب. طبعا we cannot get it exactly. طيب, then we have the value of IA multiplied by XS. How can we get it? Sorry, already we calculated that. IA by XS, it's equal to 550 volt. So in length, it's equal to 5.5 centimeters. صح كده يا شباب? So normally we draw IA by from this point. So we should make locus for IAXS with the length of 5.5 centimeter. Okay, طبعا شباب ده بالايه بالبرجل بالفرجار. تمام؟ يعني draw locus for IA multiplied by XS, and this distance from here should be 5.5 centimeters. Then we can start from the points of 0 to draw EF at 15 degrees, because we know the EF is at angle delta equals 15 here. So we can insert here another line or draw another line at 15 degrees. So we should measure the angle first يا شباب. يعني give the angle of 15. Assume this is the angle of 15. For instance, like that. So this means that the intersection of this line with the locus of IAXS will be the point of intersections of two vectors IAXS and EF. Is it clear يا شباب? So for now, the vector of EF will be this vector, and in this case, the IAXS will be this vector here. So this is now يا شباب the right phasor diagram. طبعا we have the length of V terminal, we have the length of IAXS. However, we now could draw exactly the value of EF, so we can measure EF here now. تمام؟ We can measure the length of this vector now يا شباب to get the value of EF. Is it clear يا شباب؟ يعني is it يعني clear now how we can use graphical solution to get the vector EF? واضحة يا شباب؟ Shall I repeat it?
دكتور if you can go over it again
Okay.
quickly.
Again.
نقدر نطلع باستخدام الكويشنز دكتور.
Sorry?
نقدر نطلعها باستخدام الكويشن وكذا بدل الرسم صحيح؟
في طريقة تانية نقدر نحلها بالايكويشنز هقول لك عليها حاجة. ماشي but let me first start with a graphical way. يبقى احنا بدأنا الأول يا شباب we have started with the V terminal. We know the value of V terminal, so we got a scale, or we assumed a scale that 100 volt equals or equivalent to 1 centimeter. So V terminal is 1327.9 volt. So in centimeters يا شباب it will be approximately equals 13.3 centimeters. تمام? So we draw here a vector of 13.3. Then we know the value of IAXS. IAXS was 50 or 550 volt. So we can say now IAXS is equivalent to 5.5 centimeters. So here we got a locus for IAXS. طبعا we started from that point. تمام يا شباب؟ يعني بدأنا من النقطة دي باستخدام الفرجار، يعني وقدرنا نرسم القوس اللي اللوكس او المحل الهندسي بتاع IAXS. يا شباب؟ So this is the way now we draw this curve. تمام؟ And now we need to draw EF. You already know the angle. So you can measure 15 degrees from V terminal and draw a line. This line will intersect with this curve at a point. This point of intersection is the vector length of EF. تمام? So this is the way شباب how we could obtain the EF graphically. ماشي يا شباب؟ كده الأمور واضحة؟
واضح.
So this is the first way شباب. يعني after getting the length here, we can now convert length to voltage by using our scale. طيب, by the way, this angle represents the power factor angle plus 90 degrees. ماشي, يعني if you use the angles of our triangle, طبعا يعني this is IAXS. Our current here will be lead like that. Because you know, يعني for motor, this is IA, so JIA should be in that direction. This is J and plus, so in minus it will be in the other direction. يعني if you plot the triangle to construct the right angle here, it's 90. تمام? So this is our power factor angle يا شباب. صح? This is pi. So the angle here should be 90 minus phi. Is it right? طبعا this angle is x. We can say now x equals 180 minus this angle. صح يا شباب? Which is 90 minus phi. So the resultant will be 90 plus phi. So this angle is 90 plus phi. So by measuring also this angle, we can get the value of phi and get the power factor. طيب, this is the graphical solution يا شباب. This is now our graphical solution. Can we use another way based on the triangle analysis? يعني you know now for the case here, for any triangle, شباب, let me first draw the triangle in order to get a relations. يعني for such triangle يا شباب. This is, let's say first شباب يعني A B C. This is vector A or يعني length or piece A, B, and C segments of the triangle. And let's say this is angle A. Let's make it small letter angle A, which is facing the side A. This is angle C, and this is angle B. We can say, شباب, you know that A, the length of A over sine A equals length of B over sine B equals length of C over sine C. You know this relation يا شباب؟
Yes.
دي حساب مثلثات يعني for that A here can represent our case IA multiplied by XS. C here represent our vector V terminal. B here represent our vector EF. So you can get a relation from here. You can say now A, which is IAXS, you can say IA multiplied by XS over sine A. What is A here يا شباب؟
15.
Which is delta. Let me write the equation in general. تمام. So it's over sine delta equals B, which is EF, over sine angle B, which is here 90 plus phi. صح يا شباب؟ Equals last thing C, which is V terminal, over the last angle here, but this angle is not a يعني defined in our يعني phasor diagram. So this is the way شباب to use it in order to get also our يعني angles and vectors. طب now what is given here in our problem? يعني IAXS you have it. So you have this length. You have this length as well. And you have this angle. So we can use this angle with this length. تمام? And use this length to get this angle. Is it right? And if you got this angle, you can easily calculate the angle B and get phi and a power factor. If you could get the phi and power factor, so you have now power factor with current. تمام? So in this case, you can continue analytical. You have IA and angle phi. You can continue analytical and compute EF, or use also the relation here. You get the angle B, so you can use it to get EF. So this way can be used here. Right. Sometimes we have voltage, 2 voltage with angle يا شباب. يعني instead of having here the طبعا يعني if we have EF and the delta is given, so we can use the graphical solution, analytical solution. However, also you can use graphical. يعني if you have 2 sides of the triangle and the angle between, you can use the cosine equation. Cosine equation says that this line or this side A square equals B square plus C square minus 2BC multiplied by cosine the angle of A. يعني this is the cosine A relation of the triangle. So you can use it also يعني up to the given data and up to the required data in your problem. تمام؟ So this is it can be used as analytical solution يا شباب, and the one here can be used as graphical solution. تمام؟ So you can use any to calculate the required data here. هل في مشاكل كده يا شباب؟ هل الامور واضحه؟
Yes.
So this is the way شباب يعني we can use to calculate anything using graphical or a triangle analysis. Let's solve another problem here related to power factor compensation. We have a factory. This factory takes 600 kilovolt ampere. So this is our load. 600 kilovolt ampere at 0.6 power factor lagging. So power factor here equals 0.6 lagging. Then a synchronous motor is to be installed to raise the power factor to 0.9. So here, this is our bus bar of the factory. Okay, this is our bus, and it's desired to add here a synchronous motor. Why we add a synchronous motor here? To deliver some reactive power in order to compensate the power factor. So after adding the synchronous motor here, the overall power factor was 0.9. So we have now 0.9 power factor lagging after adding the synchronous motor. And it's stated that the synchronous motor itself taking 200 kilowatts. So we have mechanical load and it's working at 200 kilowatts. Calculate the corresponding apparent power in kilovolt ampere taken by the motor and the power factor at which it operates. So now we could get we designed a proposed value for the overall power factor to be 0.9, and based on that we need to calculate now how much apparent power the synchronous motor will need and what if the power factor should be adjusted to in order to compensate the overall power factor to 0.9. Is it clear يا شباب؟ طبعا it's a matter now of power calculation. It's not related to the motor anymore. يعني all of this problem here can be solved for the students of a junior student, not for the sorry, you are junior students already. For other students who just know the electrical circuit basics, and sophomore student or maybe freshman can calculate this problem. طب let's يا شباب يعني just refreshing your knowledge. This is just now electrical circuit. We can assume that load can be subscribed as 1. So if we said B1, this means the power of load. So B1 equals, we have S and power factor. So what is the power يا شباب? How we can get the power of load?
S times the power factor.
Exactly. So S1 times power factor 1, which is 600 kVA multiplied by 0.6. So this is now 360 kilowatt. This is B1. But what about reactive power 1? Q1. يا شباب. طبعا we have, this is the power triangle يا شباب. This is Q, this is B, this is S, and this is the angle A, phi. تمام? So we can say Q equals S sine phi. Is it right? So S1 sine phi, and sine phi is nothing but sine cosine inverse power factor 1. So we can say now S1 600 multiplied by sine cosine inverse 0.6 is 0.8, which is 480 kilovar. So this is now the power and the reactive power of load. طبعا this value يا شباب is inductive، صح ولا غلط؟
Yes.
It's inductive because the power factor is lagging. طيب, this is for our load. For our overall system, sorry, for the synchronous motor, so assume that synchronous motor is number 2, load number 2, and now we can calculate for load number 2 يا شباب. We have the power, which is 200 kilowatts, so B2 equals 200 kilowatt. However, we don't know the value of Q2, it's unknown, and power factor 2 also is unknown, يعني it's required. يعني what are required? Power factor 2 and S2. These are the requirements here. Right, for load or overall now for all of the factory, so we can say factory as total or 3, we can say 3. So we can say B3 يا شباب equals A, in terms of other values. يا شباب, B3, the power at the bus bar here equals what?
The
B1
summation.
Summation, exactly. So it's B1 plus P2. So here يا شباب it will be 360 plus 200. تمام كده يا شباب؟ $560 kilowatts. This is our power, and the Q3 can be obtained by the data of new power factor. We have now the new power factor of 0.9. So from the power triangle again, we can say that if this is the power triangle B, Q, S, and this is phi, we can see here tan phi equals Q over B. So Q equals B tan phi. So we can say it's equals to B3 tan phi, and phi is nothing but cosine inverse power factor 3.
3.6.
So we can say now 560 multiplied by 10 cosine inverse 0.9. 560 multiplied by 10 shift cosine 0.9, which is 271. So Q3 here يا شباب 271.22 kilo volt ampere reactive, and also it's inductive. Why it's inductive يا شباب? Because it's lagging power factor. طيب, now
Why we take 0.9, not 0.6?
0.6, is it stated in the problem that the factory power factor is 0.6? It's stated here that we need to compensate the power factor to 0.9. Is it right?
Oh, okay.
تمام؟ يعني don't mix شباب between يعني different cases. يعني for that I made here subscription 1, 2, 3 like that. تمام؟ We have power factor 1, which is here for load. Power factor 2 is for the motor. Power factor 3 for the overall power of the factory. تمام؟ So we got now Q3, and now based on the discussion, we know that the power, the reactive power, which will be absorbed by the load, can be obtained from supply and motor as well. So we can say now Q1 equals Q2 plus Q3. تمام? We need Q2, so we can say Q2 equals Q1 minus Q3. So simply we can say now for synchronous motor, Q2 equals Q of our load minus Q of the supply. So the required power of the load was 480. So we can say 480 minus 271.22. It's 208.7 kilo volt ampere reactive. So this is now شباب the reactive power of our motor. طب now we need to get the apparent power of our motor. So S of synchronous motor equals square root of 2 B2 square plus Q2 square. So you have the power of 200 kilowatts plus 208.7 square. This is going to give you the amount of apparent power, which is here 289.12 kilo volt ampere. بس kilo volt ampere. Okay شباب, so this is now the amount of absorbed, or sorry, delivered kilovolt ampere. طيب طبعا شباب, now we easily can calculate the power factor of our motor. Power factor of the motor, so power factor 2 of the motor can be calculated as power over S. So it's 200 over this value, 289.12, which is 0.69. طبعا 0.69 here يا شباب, is it lagging or leading?
lagging.
How it's lagging? يعني if it is lagging, we should say from the beginning Q1 plus Q2 equals Q3. صح ولا غلط؟ يعني if it is lagging like that, so we should say Q of load plus Q of motor equal Q of the supply. However, we add the motor in order to compensate the power factor. So the logic to be leading power factor in order to deliver reactive power. صح يا شباب؟ So the power factor of motor is leading, not lagging.
دكتور
تفضل.
احنا قلنا في السynchronous machines اذا استخدمت في الحاله هذه في data class انه يكون الباور انبوت زيرو.
لا, it's not a condition. Again, we said, يعني what we said exactly in our class. If you have synchronous motor on the shelf and it's not used anymore in your factory, you can use it at no load in order to operate completely as synchronous condenser. However, if you have already the motor is working and driving certain power, should you disconnect the power to improve the power factor? It's not logic. تمام?
Okay, so in this case we have a desired power factor we want to compensate to.
Yes, but take care, يعني here this problem says it's required to compensate the power factor to 0.9. However, the proper design should be like that. First, you should know the value of apparent power of your motor. And based on that, you should use the overall capacity of the motor. يعني here this motor, for instance, we get now S equals 289. If this motor can work up to 300 kilovolt ampere, so this means that you can deliver more reactive power. Is it right or not?
Right.
تمام. طب if we can يعني supply more reactive power, why not we shouldn't supply? What I see, you should operate the motor at full capacity, تمام, to draw the rated kilovolt ampere and deliver the maximum possible amount of reactive power, but without overloading the motor. Without overloading means to only operate at S rated. تمام. This is in order to give sufficient power for surrounding loads. تمام؟ I
Sure.
believe if we do that, we can improve the power factor more than 0.9. تمام؟ However, we should make the calculation يا شباب first. We should get the rated power here. We should see what is the power factor. يعني if we, in this problem يا شباب, if we state that the motor here is 500 kilovolt ampere or 300 kilovolt ampere. Can we add another يعني part here? يعني here the problem finished at this part here. Let's say another part. Number B. For the same motor, if the rated kVA is 300, or if the motor is, if motor is 300 kVA, calculate the maximum possible reactive power can be used without overloading the motor. Is it clear يا شباب؟ يلا عايزين نحل المطلوب ده يا شباب. يلا هنعمل ايه؟ Now we have 300 kilovolt ampere available. Let's see for how much can we يعني compensate the power factor here. ها who can solve with me يا شباب؟ First شباب, let's get the amount of a reactive power, the possible amount of reactive power. Is it right?
Yes.
طيب how we can get it يا شباب؟
The same requirement.
With the same requirement, we have 200 kilowatts absorbed from the synchronous motor, and now we need to see what will be the new power factor of the overall system, تمام? Based on using the motor at rated kilovolt ampere. Is it going to be more than 0.9 or not? This is like a design problem يا شباب, like what we use in our life. So for that يا شباب here, the capacity or the full capacity, we can need the calculate the reactive power. So we can say Q for synchronous motor equals to S rated square minus B2 square. So we can say now 300 square minus 200 square over square root of 2. What will be this value? 300 square minus 200 square. So this is here يا شباب 200 23.6. Is it higher or lower than the one before? It's lower. So instead of 300 يا شباب, let's say 500. يعني assume this is 500. So here we can say
It's higher.
Can say 500 instead. Okay. So for 500, it will be 458. ماشي. So we have here available $458.25 kilowatt. So the motor can deliver this power. But the question here, do we need this power or not? ها شباب. Do we need this power? يعني now the motor can supply up to 458 kilovar. Do we need this power for our factory? Let's go to
No.
the problem again here. The factory needs 480 kilovar. So we need it, is it right?
Yes.
So we can use the rated. In this case, we can use this value. Now, if we use this value now, what will be the power factor of the system? I mean the overall factory. تمام? So we can say now power factor of 3, which is referred to the factory, can be calculated as شباب cosine phi or cosine phi equals B over S equals B3 over SA3. B3 will be the same, which was 560, I believe. 560 kilowatts. Over the new apparent power. What will be the new apparent power يا شباب? We can say it's 560 squared. This is B total. تمام? Q total. What will be the Q total now? If the motor can supply 458 and requires 480, so we can say here Q3 equals 480 minus 458.2. This is 21.7. So this is now 21.7. So the supply should deliver reactive power of 21 kilovar. Okay, it's still برضو inductive يا شباب. Still inductive in this case. So it's plus 21.7 squared. This is the total apparent power.
It's almost 1, 0.99.
جميل. يعني someone has calculated it's 0.99. So we can do that. طب what will happen يا شباب if the apparent power of the motor was 600?
You don't need the extra.
You don't need the extra. In this case, you will take only the 480 kilovar, okay, and operate the machine, the factory at unity power factor. تمام يا شباب? Is it clear? يعني the concept of state of the art of power factor compensation يعني I wish يعني to be clear in this يعني way. طبعا يعني we finish the class like that today. يعني I hope the problems could help you in more to understand the synchronous machine. Inshallah, we may start also next class with solving some problems and start in the new topic. طيب any question يا شباب؟